Hello students. Welcome to Varun Tutorials. In this video, we will learn about Newton's law of cooling, which describes how a hot body cools down in a surrounding medium. We will state the law, derive its mathematical formula using differential equations, and solve practical examples to find the temperature of a body over time. Let's study Newton's law of cooling. The law states that the rate of change of temperature of a body is proportional to the difference between the temperature of the body and its surrounding medium. Let theta be the temperature of the body at time t, and let theta 0 be the temperature of the surrounding medium, which is usually air. According to Newton's law of cooling, we can write the relation mathematically. d theta by dt is proportional to theta minus theta 0. Introducing a negative cooling constant, we get d theta by dt equals minus k times the quantity theta minus theta 0. Here, k is a positive constant, and the negative sign indicates that the body is cooling down, meaning its temperature decreases over time. To solve this differential equation, we separate the variables. This yields d theta over theta minus theta 0 equals minus k dt. We label this as equation 1. Next, we integrate on both sides of the equation. This gives the integral of d theta over theta minus theta 0 equals minus k times the integral of dt. Integrating, we get log of the quantity theta minus theta 0 equals minus kt plus log c, where log c is the constant of integration. Combining the logarithms, we have log of theta minus theta 0 over c equals minus kt, raising both sides to the exponential base, we get theta minus theta 0 over c equals e to the power of minus kt. Multiplying by c and rearranging, we obtain the general solution, theta equals theta 0 plus c times e to the power of minus kt. We label this as equation 2. Let's solve the example. A body is originally at 80 degrees Celsius and cools down to 60 degrees Celsius in 20 minutes. If the temperature of the air is 40 degrees Celsius, find the temperature of the body after 40 minutes. Let's write down the given parameters from the problem. The surrounding air temperature theta 0 is 40 degrees Celsius. Initially, at time t equals 0, the temperature of the body theta is 80 degrees Celsius. After 20 minutes, the body temperature cools down to 60 degrees Celsius. We use the governing equation derived from Newton's law of cooling. Substituting theta 0 equals 40, we get the equation theta equals 40 plus c times e to the power of minus kt. We substitute our first set of boundary conditions, t equals 0, theta equals 80, to determine the constant c. This gives 80 equals 40 plus c times e to the power of 0. Since e to the 0 is 1, we get c equals 40. Next, we plug the value of c equals 40 back into our governing equation. This gives equation 3, theta equals 40 plus 40 times e to the power of minus kt. Now, we substitute the second condition, t equals 20, theta equals 60, to find the cooling constant k. This gives 60 equals 40 plus 40 times e to the power of minus 20k, subtracting 40 from both sides gives 20 equals 40 times e to the power of minus 20k. Dividing by 40, we get e to the power of minus 20k equals 20 over 40, which cancels to 1/2. Taking the reciprocal gives e to the power of 20k equals 2. Taking the natural logarithm on both sides of the equation, we get 20k equals log 2, which gives the cooling constant k as 1 over 20 times log 2. Let's substitute this value of k back into equation 3 to get the specific temperature formula. We obtain equation 4, theta equals 40 plus 40 times e to the power of minus 1 over 20 log 2 times t. To find the temperature of the body after 40 minutes, we substitute t equals 40 into equation 4. This gives theta equals 40 plus 40 times e to the power of minus 1 over 20 log 2 times 40. Let's write down the related logarithm and exponential rules to simplify this expression. The exponent simplifies to minus 2 log 2, so the expression becomes 40 plus 40 times 1/4. Calculating the values, we find theta equals 40 plus 10, which equals 50 degrees Celsius. Therefore, the temperature of the body after 40 minutes is 50 degrees Celsius. Thank you for watching. If you found this helpful, please like, share, and subscribe to Varun Tutorials. Turn on notifications so you never miss a new video.